So hopefully this is a very short video, within 5 minutes, maybe 6. This is all about transferring thermal energy. So in the last video we talked about what thermal energy is. It's the sum of the kinetic and potential energy of the particles in an object. It talked about heat, temperature, etc. But how does thermal energy transfer? So how does heat go from a higher temperature to a low temperature? How does that thermal energy get from one place to another? Well, there are three ways to transfer thermal energy. The first one is through what's called conduction. So conduction is when there's a physical transfer of thermal energy in solids. So again, this is when two solids touch each other, and that is the most important part. They have to be touching. So this is, for example, if you put your hand on a hot stove, if you hold an ice cube in your hand, if you feel someone's forehead to see if they're sick. This is conduction. It is physical contact between two solids. Another way, example, touching hot soap. Another way to transfer thermal energy is through another C word called convection. Convection is the movement of warmer and cooler energy from place to place in fluids. A fluid can be a gas or a liquid. So for example, hot air rises and cooler air sinks in a cycle, and it just moves in a cycle, like a furnace. Another very classic example is if you ever cook macaroni and cheese, you wait for the water to start boiling, and then you put in the macaroni, and you can see it kind of turn around, move in a cycle. That is the convection. The hot water rises to the top, then it cools down and sinks towards the bottom where it gets reheated and it rises back up, cools at the top, sinks back down over and over and over again. This is also how a lava lamp works. I know a lot of people don't know what a lava lamp is. It's not real lava. It's just this goop that they put in a lamp. The lamp is at the bottom, the light source. It heats up this goop, which rises to the top. It cools down. It sinks back towards the light. The light reheats it. It rises back up, and it just keeps doing that over and over again. Those are called convection. Convection. Hot fluids rise, then cool fluids sink, and it goes like that in a cycle. The third way to transfer thermal energy is through radiation. This is the transferring of thermal energy by electromagnetic waves. Electromagnetic waves can travel through a vacuum, and they can also travel through a medium. I'll explain what a medium is in a second. A vacuum means there's no solid, liquid, or gas, like outer space. Now, granted, there are very few gas particles in outer space, but they're so far apart that, they don't even matter. But yes, radiation can travel through a vacuum. This is how we get heat from the sun. So it's very important to know the following. Convection and conduction must have a medium. They have to have a solid, liquid, or gas. Conduction is when two solids touch each other. Convection is gases and liquids rising and sinking, etc. What if you put a solid and a liquid together? Is that convection or conduction? That's technically conduction. It's two objects touching each other. But again, conduction, convection, you have to have a medium. You have to have a solid, liquid, or a gas for this to work. However, radiation does not need a medium. Radiation can travel through a vacuum. In fact, if radiation had to have a medium, the whole Earth would be frozen because we would get no heat from the sun. And just to give you some visuals for this, you can see conduction. It's the heat transferring through a solid. So if you're holding an iron, this is an iron poker. If you're holding that iron, it would feel very, really, really, really hot, which is why you have to wear a glove. And we're actually going to talk about a conductor and an insulator here in a moment. Radiation, again, radiation doesn't travel through the sides. It travels in every direction, just FYI. It's a reason why you can feel heat on the side of a flame as well as above the flame. Convection's when hot air rises, it goes straight up. So when you put your hand above the flame, not only are you feeling the radiation, but you're also feeling the convection. That's why it's way hotter if you put your hand directly above a flame versus putting it off to the side. That's just the radiation. So again, Convection, conduction must have a medium. Radiation doesn't. I'm already over 5 minutes. Oh well, get over it. So I just mentioned conductors and insulators. So what are conductors and insulators? Let's see if I can move this kind of out of the way. Not really, but that's okay. Let's do one at a time then. So a conductor is materials that transfer, and when I say conductor, I mean a thermal conductor. Because there are also things that conduct electricity, but not everything that conducts electricity conducts thermal energy. So I should have wrote thermal conductor here. A thermal conductor are materials that transfer heat very easily, like metals. Glass is an example of a very good thermal conductor, but a very poor electrical conductor. But metals and glass are good thermal conductors. Why? Why especially metals? And the reason why specifically for metals are good thermal conductors is because there's lots of free moving electrons. Lots of free moving electrons. That's what makes things good conductors. Lots of free moving electrons. An insulator then would be, I can scroll down, there we go, materials that transfer heat very slowly. So, for example, air, wood, fiberglass, cotton, water is a very good thermal insulator. It does not transfer heat very quickly. It takes a while to, if you ever boil water, you know it takes a while to do. Why? Because there's very few free moving electrons. So again, insulators are materials that transfer heat slowly because of very few free moving electrons, whereas conductors transfer heat very quickly, like metals, because they have lots of free moving electrons. So again, common conductors: brass, aluminum, cast iron, copper, steel, bronze, all metals. These are all metals. Good insulators: fur, silk, paper, wax, wool, rubber, etc., etc. If you ever get lost in the woods and you need to stay warm, a good idea is to take a bunch of leaves and just stuff them under your shirt. Cover yourself in leaves. Okay, that air, because it creates air pockets. Well, one, the leaves themselves, but also the air pockets it creates is a good insulator to keep you warm. So there you go. Conductors move heat easily. Insulators don't move heat easily. 3 ways to transfer thermal energy: conduction, physical contact; convection, the flowing of hot air to cool air; and radiation.